All right, so before we get into that guided note sheet, let's review a little bit of what we talked about last time with greatest common factor. So now we got that on your guided note sheet, okay? It says to use the distributive property to factor each polynomial, and you're given this one. Now, so what we mean by use the distributive property is this is the answer. If think of it as this is the answer to a distributive property problem, I want you to give me the original problem, but I want you to do that by pulling out the greatest common factor. Okay? So I want you to make this a multiplication problem, basically. Between this binomial, between these two factors, or these two monomials, what's the greatest common factor between these two?
4.
4. Do they have any variables in common? No. So I want you to factor out a 4, meaning you're going to bring out a 4 on the outside of the parentheses, and I want you to rewrite what's left over after you bring out a 4. You're undoing a distributive property problem here. So if I pulled out a factor of 4 here, what factor is left? A 4 is left, right? Because if I redistribute that, 4 times 4, it'd give me 16a. I'm not changing the problem, I'm just manipulating it a little bit. Okay? And if I pulled out a factor of 4 here, what's left? Just a 1b, right? Plus b. Okay. So if I want to check my answer, if I was to redistribute this, okay, I would get 16a plus 4b, which is what I originally had. So I kind of reverse distributive property here. I pulled out a greatest common factor. I rewrote inside the parentheses what's left. We factored out a GCF is what we call that. Okay, we factored out a GCF. We took out a GCF and we rewrote what's left. So the second one says it's binomial. Says 15x squared y plus 25xy squared. Binomial again. Let's factor out the GCF. Let's bring out the GCF. So let's just look at the numbers first. 15 and 25, what's the GCF? 5. 5 is the largest number that divides both, right? So I'm going to pull out a 5. I have 2 x's being multiplied here. I have 1 being multiplied here. So that means how many do they have in common? Just 1 x. I have 1 y here, 2 y's here being multiplied. So they have in common 1. So the greatest common factor between those two terms is 5xy. So I'm going to rewrite what's left over on the inside of this parentheses here. I pulled out a factor of 5 here, so what factor is left? You can think of it as if you broke this down into 5 and 3, I brought that out, so there's a 3 left, right? That way if I redistribute it, I would get this in return. I pulled out one of the x's, so how many x's are left? Just 1. I pulled out this 1y, so it's right there, so I don't need to write it. Plus, I pulled out a factor of 5 here, so what factor is left? 5. I pulled out this 1x, it's right there. I pulled out one of these y's, so I'm left with 1 there. So I factored out a GCF there. Again, if I was to redistribute these, I should get this in return. 15x squared y, I get that. 25xy squared, get that. Okay. Just bringing out a GCF. Does that make sense, guys? Try this one just a second. So this binomial, what's the greatest common factor between these two terms? They have no a's in common. They have no b's in common. How many c's do they have in common? 2. So I'm going to pull out a c squared. Okay. That's the greatest common factor they have. They have 2 c's being multiplied. So in this term, I'm left with a, b, c, because I pulled out 2 of the 3. But the question is, what's going to go here since I pulled out both of these? Yeah. Very good. It'd be minus 1. Okay. You're left with just a factor of 1 because you pulled out everything except the factor of 1. Because if you redistribute here, you would get a, b, c to the third minus c squared, 1c squared. Good. So just because I pulled this entire c squared out, I'm still left with a factor of 1. Okay. Brought that out, and that is I factored this binomial by bringing out a GCF. So now I have 3 terms that I'm looking for the GCF. It's got to have a common factor of all 3 of these. Between 4, 8, and 28, greatest common factor of those is a 4. I have two r's here being multiplied, 1r, so that means they all have 1 in common. No s's, 1s, no s's, so I don't have any s's that are common factors. So the only thing I can bring out is a 4r. I'm going to rewrite what's left over. If I pulled out a factor of 4r here, what's left over in the first term? Just 1r. Right? I pulled out a factor of 4r here. So I'm left with 2s, right? Because I pulled out a factor of 4 here, so I'm left with 2. I pulled out that r. So I'm left with s. Plus, brought out a factor of 4 here. So I'm left with a factor of 7. Again, one way to look at it, I brought out that factor of 4, I'm left with 7. Or if I divided that by 4, I'm left with 7. All right, so then the last one we have of bringing out the GCF was 9x squared plus 36. Binomial here. They don't share any x's. What's the greatest common factor between these two terms? Just a 9. All right. 4 is also a factor. 9 is the greatest one. Okay. So that means I'm left with x squared plus 4. For now, that's as far as we're going to go. That's our greatest common factor, was 9. So when we have 4 more terms, 4 or more, we're going to group them in order to factor them. We're going to try it by grouping. We're always going to look for a GCF first, though. So let's look at that first one. It's 4ab plus 8b plus 3a plus 6. 4 terms right here, right? Is there a GCF between all 4? There's not, right? There's not something that you can bring out like we did above. Okay? There's no GCF. So what we're going to try is a method called factor by grouping. We're going to start by grouping the first 2 and grouping the second 2. So what I want you to do is put a set of parentheses around the first 2 terms and a set of parentheses around the second 2 terms. We're going to group them and take them each individually. Okay? So let's look at this first term here. Between 4ab and 8b, what is the greatest common factor between those 2 terms? A 4 and a b, right? They both don't have an a. Greatest common factors for a 4 and a b. So if I brought out the GCF between those 2, let's write what's left. I brought out a factor of 4b here, so I'm left with a. I brought out 4b here, I'm left with 2. Right? Everybody agree with that? If I remultiplied that back, I would get 4ab plus 8b. Okay. So that's just grouping the first part. Let's look at our second grouping here. Greatest common factor between 3a and 6 is positive 3, right? So I want to write a plus 3. The reason I don't just write 3 here is because then it looks like I'm multiplying these together, and I'm not. I'm multiplying these together, not these 2. So I'm going to write a plus 3 here to kind of separate it. Okay. Again, the reason it's positive is because it's a positive, or the reason it's a plus because it's a positive 3 that I factored out. Don't just write 3 here because then it looks like you're multiplying these. Okay. So I bring out a 3. Let's rewrite what's left over after I factored out a 3 here. I'm left with a plus 2. Everybody with me so far? We grouped this one, we brought out a GCF. We grouped this one, we brought out a GCF. Okay. Notice in these 2 multiplication problems, this multiplication problem and this one, because remember it's multiplication, they have the same binomial. They both have a plus 2, right? What we're doing in this problem is we're kind of undoing a foiling problem now. It's a binomial times a binomial. So the first binomial of our answer is going to be what they have in common, the binomial they have in common, which is a plus 2. I'm kind of like bringing that out of another grouping. The second binomial of our answer, or the other binomial, is what I factored out, 4b plus 3. Okay. This is our original FOIL problem that would get us this answer. Okay. All factor by grouping problems, you should get the same binomial here, and that's one binomial of your answer. And the other binomial is what you factored out there and there. Okay. So you don't have to do this on your page, but you have this. Let's just check our answer. Let's say if I was to FOIL this problem, because it's a binomial times binomial, so we FOILed it. We did first, that's 4ab. Outside, 3a. inside, 8b. Last plus 6. Same thing, right? See how that works? It doesn't matter if this came first, this binomial came first, or this binomial came first. But, okay, that's a way to check our answer, that if we foiled that, that's how we got it, though. We grouped, and then we factored out what was in common of each grouping. Okay? We're going to do a lot of practice with these over the next couple of days. So, any questions to start with? This is called factoring by grouping. Let's look at the second one. Second one says x squared plus 2x plus 3x plus 6. 4 terms, they all don't have a GCF, right? There's not something that's in common with all of them. So I need to try and group them first. Let's start by trying to group the first 2. Let's start by trying to group the second 2. Between these first 2, what's the GCF between this first grouping? 1x. Just 1x, right? So I'm going to bring out 1x. I'm going to rewrite what's left over. I brought out one of these x's, so I'm left with 1x. I brought out this x, so I'm left with x plus 2. Between this grouping, what's the GCF? Just a 3, right? Remember, I'm going to write plus 3 because I don't want to confuse that for multiplication. And I'm left with x plus 2. Again, even at this point, if I remultiplied that and remultiplied that, I would get this back. I'm not changing the problem, I'm just manipulating it a little bit. Now again, at this point, we should always have the same binomial there and there. If we don't, one of two things either happened. We either factored it wrong, or you can't do it by grouping. We're going to do some examples of both in just a second. But we should always get the same binomial there and there. If we don't, we need to go back and check. So that's one binomial of our answer is x plus 2. The other binomial of our answer is what we factored out. X plus 3. And this would have been our original FOIL problem. We changed this to a binomial times a binomial instead of just a bunch of terms being added. 4 terms, all don't have a GCF. So try it by grouping. I'll let you try it first and then we'll check it together. So we group there and then just take it each binomial at a time, one at a time. 12y squared and 9y. 12 and 9 have a common factor of, the greatest common factor of 3. They both have 1y, so I'm going to factor out a 3y. After I took out a 3y here, I'm left with a factor of 4 and one of the y's. And here I'm just left with a factor of 3. Right. Again, if you're ever unsure, re-multiply back together and see if that's what you get. In this grouping, greatest common factor is 2. So I'm going to write a positive 2 is what I factored out. And I'm left with 4y plus 3. So at this point I check, are my 2 binomials the same? And they are. So that's one binomial. The other one is what was factored out. That's 3y plus 2.
What if your binomials aren't the same?
Good question. What if these aren't the same? Try the next problem, and then we'll answer that question. See what happens on the next one, and there's a minor tweak we have here. So we're going to group them. Look at the first 2 terms, 6x squared and 15x, the GCF between those two. 3x, everybody agree with that? They both have an x in common, they both have a greatest common factor of 3. So that leaves me with 2x minus 5. Right? Again, 6 divided by 3 is 2, 15 divided by 3 is 5, that's how I got those. I brought out 1x here, so I'm left with 1x. I brought out the 1x there, so I don't have any there. All right, let's look here first. Common factor, I have a negative 8x and a positive 20. 2 is a common factor. What's a greater one? 4, right? So if I brought out a positive 4, I'd be left with negative 2x plus 5, right? And looking at these 2 binomials, they're really close to the same, but they're not exactly the same. They're not exactly because I have a minus 5 here, and here I have a negative 2x. I really wish this was a positive and this was a negative. And then it'd be the same. So let's go back to what I factored out. I brought out this 4. What if I changed what I brought out? Instead of a positive 4, if I brought out a negative 4 or a minus 4, what factor would be left here? If I brought out that negative, it'd be positive 2x. Because remember, if you re-multiplied those back together, it'd be negative 8x. And then would it be minus 5 or plus 5 here? It would be minus because when you multiply those back together, basically remember two negatives multiplied make a positive. So here's a positive. This is really made up of two negatives being multiplied. If I bring out one of the negatives, I'm left with one there. Because if I re-multiply these back together, negative 4, negative 5, I get positive 20. Now, are these two the same? Yeah, they are. 2x minus 5, right? So 2x minus 5 will be one of my binomials. The other one is what? Yep. What I factored out? 3x minus 4. Four terms, no GCF between them, so I'm going to have to try and group them. Let's start with grouping those two and grouping those two. Greatest common factor between 35x and minus 5xy is going to be a 5. How many x's? Just one. How many y's? They don't have any in common, so just a 5x. I brought that out. I brought out a factor of 5 here, so the two factors that make up 35 are 5 and 7. If I re-multiply those, that's what I get, so that's good. Minus, I brought out that 5, I brought out that x, and I'm just left with minus y. In this case, greatest common factor between these two things, let's try plus 3. That will leave me with y minus 7 there, right? Brought out a factor of 3, I'm left with y. Brought out a factor of 3, I'm left with 7. Again, I need to check, are these two things the same thing? And they're not, right? Because the minus here is with the y, and the minus here is with the 7. They're close. They're not exactly the same, though. So let's go back to the second one. And instead of factoring out a positive 3, let's see what happens if I factored out a negative or a minus 3. If I factor out a negative 3 here, remember this is a positive right here. Two negatives make a positive. So if I bring out one of the negatives, one of them is going to stay. So I'm left with negative y. Again, if you re-multiplied those, you get positive 3y. Negative times negative. In this case, I brought out this negative, so I'm left with a positive 7. Because if I re-multiplied those, negative 3 times 7, it would give me negative 21. I don't want that to be a negative, because if that was a negative, it'd be negative 3 times negative 7, which would give me positive 21. And the problem says negative 21. Now, are these two the same thing? They are. Even though they're in different order, they're the same, because I have the minuses with the y and the positives with the 7. Minuses with the y, the positives with the 7. So they are the same thing. It doesn't matter how you write it, because both of those mean the same thing. So one binomial is going to be 7 minus y. Again, if you wanted to write it as this, negative y plus 7, you could. The other binomial is going to be what you factored out, 5x minus 3. Again, if you wrote this one like this instead, that's perfectly fine, because ultimately when you FOIL it, it doesn't matter. You're going to get the same thing back. We get that on the first one. GCF of P. In the second one, GCF between 18 and 27, is a 9. The question is, are we going to pull out a negative 9 or positive 9? If we're unsure, try it. But probably since this is a plus, and I know I want it to be a minus, let's try pulling out a negative first. Minus 9. If that doesn't work, go back and try the other one. So I bring that out. Oops. Bring out a negative 9 here. So what's the factor that's left?
5 and 2.
positive 2p. Negative 9 here, minus 3. Now, again, I said I wanted a minus here, but let's look at this. Are these two binomials the same thing? No, because it's the minus here is with the 2p, the minus here is with the 3. So a little tricky there, okay? But they're close enough that hopefully if I just go back and change this to a positive 9, I might get the same thing. If I pull out a factor of positive 9 here, I'm left with negative 2. If I pull out a factor of positive 9 here, I'm left with positive 3. Now, are these two binomials the same thing? They are. They're just in different order. The negatives with the 2, the negatives with the 2p, positive with the 3, positive with the 3. So one of my binomials is going to be 3 minus 2p. The other one is going to be what I factored out, p plus 9. And there's my original binomial times binomial.